Okay, so for part two, now we're doing a two-way ANOVA. The book will refer to three-way, but we're not going to do any of those. So basically when you have two factors, right? So the tables go both ways, kind of like the two-way tables of chi-squared. Um, so here you're going to have a lot of degrees of freedom because you have the first factor, the second factor, the interaction, and the overall total degrees of freedom. So categories minus 1, categories minus 2. So the number of categories in the first factor and the number of categories in the second factor. As to which one you consider the first and second factor doesn't really matter, right? Because the calculation interactions can be the same. So if it's 3 by 4 or 4 by 3, it's the same outcome as far as the calculation, and the total number is still going to be the same. It just switches the order of the hypotheses. So you'll see abbreviations of SS and okay, actually, let me actually put this in here. Equals, and we'll put SS. So you'll see SS and MS in the book for both one-way and two-way ANOVA, which is the sum of the squares and the mean squares. So the sum of the squares is what we did last time. We were doing the group mean minus the grand mean squared and times it by the n, which I think was 15 in the last problem. So we did that, and then when you divide it, it becomes the mean of squares, basically. So we just did that all in one step, basically, in the previous problem. This one will break it out a little bit, just because of how complicated it is. Okay. And then n is the number of samples in the group, which I did put in this one, which I did forget last time, because it was 45 overall, but 15 per group. Okay. All right, so the hypotheses is a little bit funny because you have three hypotheses when you have a two-way ANOVA. So you have the means of observations grouped by one factor are the same. The means the group by the other factor are the same. Well, there's no interaction between the two factors, right? So that's the three hypotheses. Null hypotheses, essentially. So some books put 1, 2, and 3. Some they put different variations as far as symbolism goes. You can put it however you want. Again, it's only right tail for ANOVA. All right, so let's take a one look here. So we have brands of detergent, Tide and Gain, and cleaning in cold, warm, and hot, and removes grams of dirt from the. So these are all our samples, basically. So is there a difference in mean? So the first factor could be Tide and Gain, or it could be the warmth, and then the warmth could be the second factor, or the Tide and Gain could be the second factor. That should be a hypothesis test. Yep. Okay, so let's go to our spreadsheet and go to the two-way, and I'm going to copy that in just to kind of save myself some time here. Okay, so there. Oh, let's center that out. Let's make it look nice, and then we'll center these out and center. I like that. Okay, so there's our 6 subgroups, I guess you would say. So I guess we'll say this is the first factor and that's the second factor because we have to decide, right? So I'm going to say we'll merge these, and we'll say first factor, right? And we'll just do bold, fill it in, and do a blue. That works. Okay, so we'll say grand mean. Top. What happened? I don't know what's going on with that. Let's drag that down to 4 of them, right? We'll say Tide mean, Gain mean, and the sum of the squares. Okay. Right, which is abbreviated SS. And we want to right shift all of those and box them up, I guess. I don't know. All right, so average of everything. It's the grand mean. That's what they tend to call, but not always. Okay, so the tide mean equals the average of all the tide, and then the average of all the gain, right? And you can also add them up and divide by, what is that, 4 times? Divide by 12, you get the same answer. Okay, so the sum of the squares, okay, So um, it's 12 per group, right? So it's 12 gains and 12 tides. So it's per group. So 12, whoops, equals 12 parentheses. Okay, then we need another set of parentheses for each group. So it's the tide minus the grand mean squared, right? That's the first square. Plus, there's only two of them. And then the gain minus the grand mean squared, and then close parens, because all of that's times to 12, which is what is in each group, basically, right? Yes. So it'll be, if I go the other way, it's going to be 8, right? Because there's 8 this way, and 8 this way, correct? Okay, so I'm going to copy this. Oh, what did I do wrong? What did I do wrong? Did I not put the multiply there? There we go. I forgot. I don't know. I thought I put the multiply. Apparently I didn't. Okay. Well, you know, you make mistakes. Okay, so I'm going to copy this. It's going to be wrong, but that's fine. And this is going to say second factor, which will, in this case, we're going to say it's the temperature, right? Cold, warm, and hot. So this will be cold. This will be warm. And this will be, we're going to copy this down to here. Delete all those because they're obviously wrong. And this is going to be the hot mean. There we go. Okay, so grand mean, average, parentheses, grand mean. I could probably use the same one, but just for argument's sakes. Right? Alright, so average of the cold, I'm going to go right there. Average of the warm, and then average of the, come on, I hate the pop-ups, hot. Oh, hot. There we go. Okay, so squares now. Okay, so equals 8 times, I won't screw that up this time, parentheses, parentheses, right? Because there's 8 per second factor, right? Second factor is cold, 8, 8 warm, 8 hot, right? So cold minus grand, right? This is the sum of squares, plus, parentheses, warm minus grand squared, plus hot minus grand squared, close paren, right? Because that's all times 8, which I hopefully didn't mess up this time. Okay, so now we need, I'm going to copy this again, and this will be within, otherwise known as the error. Okay, so I'm going to merge these two. I'm going to copy this just so I can get a, and delete that for now. Okay, so I'm going to drag this down because I need 6 of them, right? Because there's 6 groups, right? 6 subgroups. So 1, 2, 3, 4, 5, 6. And I can drag this down. Okay, so this one will say cold slash tide. And the order of these doesn't matter. Warm slash tide, as long as you get them all, obviously. Not time, tide. And then hot slash tide. Oop, I didn't put the equals. Actually, I can probably copy these, paste this, and put gain. Excuse me. Gain. Gain and gain. Okay, so we need cold, warm, and hot. And we're going to center those, box them, italicize them. I take those, copy that to there, copy that to there. Okay, because we need the average for the group, basically, right? So the groups are now, this is a group, right? That's the group there. Okay, so equals the average of that group, which is cold tide, right? And this is the average of warm tide. Again, washing in warm water. An average of the hot tide. Okay, because within groups, we're going to do what's within the group, essentially. Average of the gain cold equals the average of the warm gain and the average of the hot. Okay, so I think we're good there. So this is we need that there. We also need this here. So I'm going to copy, paste. Okay, so essentially at the end of the day, we need all these sums of squares, right? Those are the things that we need, basically. Okay, so I think I can copy one of these and go from there. All right, so equals, so this is cold tide. So cold tide is this one minus this one squared plus B3 minus E23 squared plus B4 minus E23 squared plus B5 minus E23 squared, right? So if I look up here, that's these four here, right? Because it's within group, and the overall group, right? So I do that, and I get a 2. So what I'm going to do here is I'm going to copy this, paste it here. So this one should be F now. F, 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 and F, because F23 is the warm, right? And then now these should be warm, which is C. So these should be C, 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 and C. And you notice it's those ones with the warm that's right here in F23. There we go. I'm going to paste it again. Now it's going to be G23, right? So this is going to be G23, G, 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 and G. And then the hot is going to be in column D. So column D, column D, column D, column D, right? So I look up, now it's those, just to scroll up and check. Okay, now I gotta do these ones. I'm gonna copy, let's paste this again, just to kind of cheat here. Okay, so now this is gonna go to E26. So I'm gonna put 26, 26, 26, 26. Now it's going to this particular cold, which is the gain cold, right? And now we need B6 to B9. So B6, 7, 8, 9. So now it goes to the gain cold, okay? All right, so I'm going to copy that one now because that'll be easier for the next two. Copy, paste. Right, and now it's going to be F, right? F, 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 and F. So it goes to the warm, right? And now this should be, for the warm, should be column C. So I'm going to change this to C, 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 and then C, right? So I check. That's correct now. And then the last one, this should be G26, right? G26, G, G. Uh-oh, did that wrong. We'll fix that after. G, G, G. Right, so that's now that. All right, so this is supposed to be D, column D for the hot gain, right? Column D, column D, column D, column D, column D, right? So now they go the individual within group minus that, and there we go. Okay, so this is supposed to be the sum of all those individual within groups, basically. And there we go. Okay, so the last thing we need is copy, paste, and we need the total sum of squares. Okay. So we'll call them column A, B, and C. How's that? So let's copy this. Let's copy it like that. So we're going to say column B, and we're going to delete this. And then we'll copy this. I don't know why they didn't fill in. Let's fill that in. B, C, and D. Okay. And then the last thing we need once we have them all is the SS interaction, which we'll talk about afterwards, right? We just can link all those together. Okay. So this one might be a pain because it's the entire column, right? So equals, parenthesis, so I'm going to go to B2, right? Minus the grand mean, because it's the overall, which is, again, I can pick this one or this one. It really doesn't matter. That's the grand mean. So either one works, right? And then square it. Okay, so I need to do, if I look at this, there are 8 of these in the column. So I need to do all 8 of them. So that's going to be fun. So that's going to go to B9, basically. So let's do this. So I'm going to copy, paste, change that to a 3, paste, change that to a 4, paste, change that to a 5, paste, change that to a 6, paste, change that to a 7, paste, change that to an 8, and paste, change that to a 9, and get rid of the extra plus on the end. So now if I scroll up, it's got, this is my grand mean, it's comparing all of those, correct? Okay, so that takes care of column B. I'm going to copy that whole thing, paste it here. So the grand mean's not going to change, but the column to warm will. So it just changes to C, doesn't it? So all of these just change to C. Change all those to C. I don't need that anymore. Oh, crap. C, C, and C. All right, let's double check. Scroll up. Now it's all C, right? Grand mean doesn't change. It's the overall table. All right, so I'm going to paste that here. And now this one should be column D, right? So column D all the way through. So a lot of this is knowing the quick way to do it and not actually going through and manually typing them all over again. Okay, so I think we got that. And then the sum of all those. There we go. All right. So basically what we did is the sum of all of them. Every single cell, basically. Right? Because this covers all the B cells, all the C cells, all the D cells. So that's the sum of every single square, basically. So it's basically the square of all those together. I just did them in groups so I wouldn't mess up, basically. Because if I did these all in one, which is typically what the book does, the chance of me getting it right is slim to none, because I have to put in, 24 of them. So I'm probably going to get that wrong. Okay, so I go back to my formula here. Did I put in the... I don't think I did. Let's put that in. I forgot to do that. So the SS interaction Okay, that is the SS total plus the SS factor 1 plus the SS factor, no, it's subtract, I'm sorry, why did I say that? Subtract. Okay, and then minus the SS within, right? So sum of the squares, basically, which is the things we did all the way down through our table. Okay, and then the order of these would vary, of course, but well, obviously the total is the highest number, so that always comes first, but these vary from book to book. Some books put the within first, but it doesn't really matter. It's going to be a positive number either way, so that's the formula. Okay. All right, so I'm going to copy this whole thing to our spreadsheet just so we have a little cheat sheet here. Okay. All right, so we're going to take the total, right, which is every single little cell, minus the factor 1, minus the factor 2, minus the factors within, and I get there's my SS interaction, basically. Okay? Okay, so those are all the SS's we need, basically, to be able to do this. So let's go up to here and perhaps make a table. Let's drag this up, too, because we're going to need this in case you don't remember it. Okay. All right, so how about right here, we say A nova. It's a two-way. We're just going to say A nova, right? And we will bold, center it, blue it, box it. All right, so the source of variance. Okay. So we need the brand, the temp, let's spell it out, why not? Interaction, and within. Okay. Yeah, that's probably good. Bold, yellow, yellow. I don't know why I yellow. Come on. Why did I change the text? I don't know. Alright, so this is basically hypothesis 1, hypothesis 2, hypothesis 3. And those can... no. I got that wrong. Sorry. I'm not paying attention where I'm typing. 2 and 3. Alright, I can delete that and send these to the right. The order of these can vary a little bit, but the brand and the temperature are definitely the two factors. As to which one is 1 or 2, it doesn't really matter. The H3 interaction between them, right? Are they dependent or independent? That's definitely always the third hypothesis, if you want to call it the third, right? Okay, so we need SS, degrees of freedom, MS, F, p-value, and the F critical. Okay, so we'll center all those out. Yellow, bold, and we will box. Okay, so these we already have. So the first one, let's send these to the right actually. Okay, so this one is this one. Temperature is this one. Interaction within is oh, I forgot. What am I doing? Within. I don't know what I was doing there. Sorry, I'm half paying attention. Okay, there we go. Nope, we did that to the right. Interaction. And then the within. Okay, we got all those things there. Okay. Those are all our sum of squares basically, right? Which is these things here. All right. Okay, so degrees of freedom. So it's J minus 1 and K minus 1. So the brands, there's 2 brands, so 2 brands minus 1. The temperature, there are 3 temperatures minus 1, and there's our degrees of freedom, right? Let's see. First factor, second factor. So the interaction, right, is going to be the 2 minus 1, right, times the 3 minus 1. There's our degrees of freedom. And then the within, it's if you look in the within degrees of freedom, did I forget to put that? I might have. Okay. Well, anyways, 24 minus parentheses 2 times 3. Okay. So I apparently forgot the within, but that's fine. So it's the total number. So I have 4. 1, 2, 3, 4, 5, 6 times, that's 24, minus 2 times 3, right? So that's what it is, basically. So let's go back to our notes. So degrees of freedom, and then we'll put within, right, equals, how do I want to put this? So n number of samples, right, minus, and we'll put J times K. That is the correct formula. Okay, I like it. Okay, so now we have the correct numbers. All right, so MS, right, it stands for mean of squares, right? So I can put that right here. So MS mean squares, right? Squares is MS, right? And then sum of squares is SS, which I think I put in this here. Yeah, mean of squares, MS, sum of squares, right? So when you divide by degrees of freedom, right? The mean of squares is a little bit different from the previous one, but for one way, but two ways the same. All right, so equals this divided by this, right? Sum of squares divided by degrees of freedom. Get your ratio. Drag that down. There is all our mean squares. All right, so our F value, right? Let's see here. It's the MS for the factor divided by the error, essentially. Okay, so there's our MS, and the error, right, is J6, which is the within. That is the error, basically, because you're comparing it to the overall. Okay, so equals this divided by the error equals this divided by the error, right? And that's the only F values you have, because this is your error. This is why we need this on the table, basically. Okay, so we're using this little formula right here. MS for the factor, right? The factor is the brand, the temperature, and then the interaction. And then because it's your 3 hypotheses, right? Then we can get our p-value, so that it's always right tail. So F dot distribution right tail. Okay, you're going to click on this for our F value. And the degrees of freedom is where people mess up. They tend to click on these two. No, click on the one you're doing for that one, comma, the error, right? And close paren. Okay, let's do it a couple more times, right? So F dot distribution right tail. You click on the F value for this one, right? That one's degrees of freedom, and then the errors to degrees of freedom. And then last one, F dot distribution, right? Click on the F value, those degrees of freedom, and then those degrees of freedom for the error. Uh-oh, what did I, oh, I didn't do dot right tail. I did the wrong one, I apologize. Okay, so those are all right tail, basically. Okay, and what you'll see is these are all very small. So if we use the Fisher rule 0.05, essentially it didn't, you end up rejecting all of them basically as far as the null hypotheses, which are these here, which we'll write in a minute. So if you think about the critical values, right, F dot inverse right tail, right, 0.05, comma, degrees of freedom, comma, this, right? You can do the 5%, or you can do the f dot inverse 0.95, comma, boom, comma, boom, right? You get the same value either way, right? Because essentially what we're looking at here, let's go to my tool. All right, f distribution is an asymmetrical, right? So I have 0.95 and 0.05. It doesn't have to be the Fisher rule of 5% alpha, you know what I'm saying? But that's what we're going to use. Okay, so for the first one example, this is my F critical, right? Critical. Okay, which we're going to say 4.4-ish, right? 4.41, whatever the case may be, right? So the area that I got is 0.005, which is like a little bitty area over here, right? That's 0.005, so it's very small, so it's definitely in that region. And my F value is 9.8 something, right? 9.81 ... right? Because obviously over here it'd be smaller, and as you go over here it's bigger, right? And this is my actual F value, so it's actually in the critical region, basically, right? And as you go through all of these, you'll notice that these are bigger than these, right? And these are smaller than 0.05, which means there's smaller areas on the end. So if I do the rest of these, f dot inverse of 0.05, comma, degrees of freedom, error degrees, and then f dot inverse right tail, 0.05, comma, degrees of freedom, comma, error degrees, right? You'll notice that all of these critical values are smaller than these. So these F values are more to the right, basically, right? So each time what's going to happen for every single one of these is you have an F critical, right? Whatever that happens to be in each 3 cases, right? And then these values are always more to the right of it, so they're always going to fall into the shaded critical region, basically. Okay? All right. So let's go back to the notes now. So what would our 3 hypotheses be? Okay, so first off, the mean observations for the group by 1 factor are the same. So what is the first factor in our case? Our first factor, according to us, is brand. So basically, the brands do not have the same mean. We have enough evidence to conclude there's not the same enough, right? The means to observe for the other factor are the same. So the second factor is the temperature, which means the means for the temperature are not the same. Okay? We've found enough evidence to likely conclude, not absolutely, likely conclude the means are not the same for temperature either. The third hypothesis is there is no interaction between the 2 factors, which means they're independent. So we're finding that they are dependent. So the temperature and the brand are also dependent. So basically our hypothesis test, we rejected the null hypothesis in all 3 cases, basically. So our hypotheses would be basically that the brands have the same mean, the temperatures have the same mean, and the third one would be the brand and the temperature are independent, right? In reality, we're rejecting all 3 of these. It might be some or all of these depending on the hypothesis test, but we have basically, this one's weird because we have 3 different p-values and 3 different null hypotheses, right? That's what's weird about this one with the 2-way ANOVA. That's why we're not going to go to 3-way, because it gets even more complicated. There is some kind of interaction. As to what the interaction is, we don't know. We have to do further study, but we're not going that far in depth, essentially. Okay, so I'm not going to write all these out, but you get the general idea. Okay, that's the end of part 2.